So let's see some concepts here today. Let's talk about abstract classes, okay? And here I can see some of the things that, some of the definitions that we can talk about when it comes to abstract classes. So abstract classes cannot be instantiated directly. So it means that you cannot create an object of an abstract class, okay? Don't even try. It will not let you create um, an object unless you remove the word abstract from the class and not make it an abstract class anymore, so you can instantiate it. Abstract classes have one too many abstract methods. Okay, it can have abstract methods. Okay, we're gonna talk about abstract methods afterwards. Abstract classes cannot be private or final. Then that can be private, they have to be public, and that cannot be final. Okay? Abstract classes that extends another abstract class inherits out of the abstract methods as its own abstract methods. So, like from inheritance, when you get, can you hold for a moment, guys? Can you hold for a moment, please?
Hello, can you hear me?
Yes.
Oh, okay. I thought my system was not working.
Processor is coming. I think that he's doing it.
I'm sorry, he what?
He's doing something. He said that can we wait and go away?
Oh, we're waiting. Okay, got it. Thank you.
Sorry, guys, someone was knocking on my door again. Okay, we were saying that abstract classes, well, when you extend an abstract class, when you say an abstract class extending another abstract class, well, that abstract class will inherit all of the abstract methods from the parent class, and it would take it at its own, okay? And the first concrete class that extends an abstract class must provide implementation for all of the inherited abstract methods. So if the abstract class has abstract methods, then if you implement that class, we're talking about a concrete class. Concrete class is a class that is not abstract. Okay. So if you inherit or you extend that class, then you will have to implement all the abstract methods from the abstract class. Okay. It has to implement it. That's mandatory. There has to be an implementation of those abstract methods from the abstract class. Okay. Okay. When to use an abstract class? Okay. Well, you want to share code among several closely related classes like animal, name, age, things like that. You want to share that code. You expect that classes that extend your abstract class have many common methods of fields or require access modifiers other than the public, protected and private. Okay. And you want to declare so you want to declare non-static or non-final fields like name, age. So this enables you to define method that can access and modify the state of the object, get name, set name. Well, abstraction is just to, hide the implementation of when you create an abstract class, you don't have to implement that there. You can implement it in another class. So you are just hiding the implementation of the details, right? It's like, well, abstraction is one of the four pillars of object-oriented programming. If you sell a car to a customer, the customer doesn't care what's going on inside the hood, right? So that's being abstracted away from the customer, right? You don't have to the customer may read the manual, right? Read the manual and try to understand how the different features of the car work, but the customer doesn't need to know what about this, how the radiator works and things like that. That just abstracted away from the customer, similar to in Java. When you abstract things in Java, you're trying to hide the implementation of the details of the car, in this case, of the class. So you're abstracting that away from the customer. One of the questions they may ask you in an interview, for example, if you try to get a job as a developer in Java, they ask you, what's the difference between abstraction and encapsulation? Well, encapsulation is the hiding of the data. You're trying to hide the data, right? Abstraction is the hiding of the implementation, right? You don't want people to know what's going on, right? And you don't want this. When we see interfaces, you're gonna understand this a little bit better. But for now, you need to understand that we're trying to hide the implementation of the details, right? I will send this to. Let me see if I can forward this. Yes, can I do that? Yes. So I'm gonna put it in the Oracle Certified General guy. So it's right now it shows here. Okay, perfect, good. So let me go back to this guy and let me create a class. We're gonna create a class, an abstract class, right? And the class is gonna be animal. We're back to the animal thing like our last class, okay? And I know that Maria likes this so much, that's why I decided to go with animal, right?
Thank you so much. I do appreciate that.
My pleasure.
Happy Thanksgiving to you too.
So we should have a class named Turkey, right?
Yeah, really. That's a good idea.
Yeah, that extends the word bird, the class bird. Okay, so we're gonna create this class. It's gonna be very similar to the class that we saw before, but you know, it's good to see this, you know, all the time. There's gonna be like um, some differences between this animal and the previous animals that we created. Um, so now I'm gonna say name, string name, right? But this class, I want to make an abstract class, right? So I'm just declaring this class abstract, okay? And as you can see, it changed the color immediately. Before it was blue, now it's yellow. I'm not sure why, but that's how IntelliJ shows it, okay? So we're making this class not instantiatable. You cannot instantiate this class. So if I come here and create a package, right? And I say abstract class main, right? And I create abstract class main. I did the same thing again. Okay, let me delete it. So I'm going to create a package what I have to create. Okay, so abstract class main, right? And now I'm going to create a class main, right? Like we always did before, we're doing the same thing. Now, if I try to just instantiate the class animal, right? Right? And it's an animal equals new animal. This class, it says animal is an abstract class, cannot be instantiated. So you cannot instantiate a class, an animal class, right? Because it's simply abstract, right? It's an abstract class, okay? So now I'm going to have our constructor like we always did before, right? And now it's going to stay like that. I'm not going to do anything else. It's just the constructor that I created with no argument, okay? Now I'm going to create another constructor, but this time it's going to take two arguments, okay? The argument is, only one argument, int age, right? And now we're going to say sysout animal, right? We're just printing that what that constructor is called, is invoked. That's going to be printed, right? And we're just going to just assign age to age, right? But this age is not the same as this age. Two different ages. This is the value that we pass when we call this constructor, okay? And this is just the variable here of this class, okay? Now let me create a getter for age, public, right? Int get age. We're just returning an int, right? And then we say return age, okay? Now we're gonna do the same with the set. So we say public void because we're not returning anything. And so we say set age, but now we're passing age, okay? When we just invoke this method, we're gonna pass an integer, right? And now we're gonna say this age equals age, just like we did in the constructor, okay? Now we're gonna do the same with name, okay? I can copy and paste these guys and just change the names, tweak it, right? So we say name here, right? And then we return the name, right? And I can say name as well here. Well, actually name here, right? And we're returning a string here, that's why, right? And then here we're saying set the name, and we pass the name, right? And here we're just assigning name to this name, okay? Perfect. So now our animal class is a little different from the class that we created on Thursday, right? We're gonna include 3 more methods similar to the ones that we created on Thursday. So we're gonna say public void, eat. And then we say sys out, animal is eating, right? The other one is public double. We're returning a double. And it's get average weight, right? And we say return 10.0, right? And then the last one, but not least, is public void print details. And then we say sys out name equals name. And then we say age equals age. Perfect. Just like we did last week. Okay? This is the animal class. Okay? Where's the animal class? Oh, right here. Right? This is the animal class. Right? So now let's create a bird class. A bird class. Bird class. Bird class. Okay? This class is going to be a concrete class. We're not making this class abstract. We're going to have a method, a public method that returns nothing, just void. Okay? And we're going to call it fly, just like we did last week. Okay? And then we're going to say bird is flying. Okay? Perfect. Right? And then we have another method that says public void, and the bird also eats, right? So we say amount. This is, we're just passing that. And then we say system out bird is eating amount units of food. Okay, perfect. We're done with the class bird. Now we're going to create the class cat, right? Okay, so the class cat, and we're going to extend animal, right? And now we say public cat int age super age. Perfect. So the class cat is done. It's finished. Then we have a class dog now. Okay. Class dog. Now dog also stands animal. Right? And then we have constructor dog is receiving an age, right? And we say super age, and we say sys out dog. And now we're gonna override the eat method, okay? And we're going to call this the parent eat method, and also we're gonna say sys out dog eating, right? And now we're going to say get overweight, but we don't need this guy, right? And then we say return overweight plus 20. Okay, that's the dog class. Now let's create an eagle class, right? And then the eagle class is going to extend bird, right? Right? And we can say fly, but we're not overriding. We are, what is this, guys? What am I doing here?
Overloading.
Overloading, right?
We're loading.
So we are overloading. Eagle is flying at meters. Right? Overloading. And then we do return, actually we're returning an integer, right? We return the height, okay? Right? Now we're gonna create a class called Husky, okay? Husky. Now Husky extends dog, just like we did last week. Now we have to put the constructor, and the constructor is gonna take an age, and then we have to say super age, and now we're gonna say this out Husky. Right? We can override eat, right? And we can simply put this at the end and say this out Husky eating, right? So that will be all with Husky class. Let me create a class called Rabbit, okay? Rabbit class. Those are classes that extend the animal class, right? So extends animal. And now we say super. Actually, public rabbit. And then we can say super. Remember that the animal class has a constructor that doesn't take anything. Okay, so this rabbit is just invoking that constructor right here, and it's not passing anything. Okay, now we can have another constructor that actually resemble that one, and then we say super h, right? This time we're gonna say a value 3. Okay, you can just put a value if you want to. Okay. Now I'm gonna create a reptile class, right? Reptile class, and this class doesn't extend anyone. And we say protected. And guys, remember what's the scope of protected?
Cannot change it.
Do you guys remember what's the scope of protected?
The final is that you cannot change it.
Remember, protected can be seen only by the classes that are in the same package, and classes that are subclasses in the same package.
Yeah.
Okay. Good. So we have this class reptile done. We have the class snake. Okay. And the class snake will extend the class reptile. Okay. Right. And then we have the method has legs. So we just override it, right? And instead of returning true, we are returning false. So we're just overriding the method, right? Right? And then we're going to override getWeight as well, right? But now instead of returning 2.0, we're going to return 10. So we're just overriding that method. Okay? Right? And then finally, in the main class, right? In the main class, we're going to say Husky equals new Husky 5. I have to import the class Husky. Okay, for that to recognize that. Okay, and now we're gonna say Husky dot hey. Oh, I'm doing this outside the main. Sorry, guys. I have to create the main method and then do this. Now I'm able to see this print details. Okay, perfect. Let me run this guy and see what happens. Okay. So we get animal, dog, Husky, and name null because we have to do some naming here. Husky dot send name, right? And then we say Jimmy, right? Jimmy. Now if I just run it, I get Jimmy here, right? Jimmy's here. Perfect. Now we're getting the same thing as last time. So we're just invoking the constructor of the class Husky. We come here, Husky, right? Husky here. And then we call this constructor because we're passing an age, right? So the first thing that it does is just call these super constructor with the age, which is, in this case, is 5. So it calls the constructor from the class dog, right? And this will also call its parent constructor and pass the same age. That's why you get first, you get animal, right? Then you get dog. After this guy calls this one, then he prints this one. And then you get Husky that prints this one after it calls the super constructor, super class. Okay, so far so good. Perfect. Now, guys, see something. Can we extend an abstract class? Can we extend an abstract class?
Yes.
No, we can't. I'm sorry. My bad. That's not the question. That's not the question.
Okay.
That's correct. That's correct. I'm not trying to ask that. I'm trying to ask what's coming next. Okay? Dog equals new dog. And then we say 3. Okay? Perfect. So let me pull this class. Can we instantiate an abstract class? Can we instantiate an abstract class? Well, you will tell me now.
Okay.
You will tell me now.
No, you cannot do that.
Well, tell me now. It says here. Well, import the class animal from this. And now I get this. Abstract class.
Get an error. It's an abstract.
In
Cannot be instantiated. Yeah.
Correct. But you can instantiate.
You can extend an abstract, right? You can extend an abstract class through other public class and access it from there, but you cannot instantiate it directly.
Correct. So you can instantiate a class that extends an abstract class, but you cannot instantiate an abstract class. Okay? So dog extends animal, right? We cannot instantiate animal, but we can certainly instantiate dog and have access to animal information. Okay, so now if I print, let me see main here. If I print dog, or they say dog that set name, right? And I say Rex, right? And I can say dog that print detail, then I'm gonna get, here we get animal as well, but animal is an abstract class, right? But I can access my abstract class from a concrete class that extends the abstract class. Because dog is a concrete class. It's not abstract. It's concrete, right? Animal is abstract. I cannot instantiate animal, but I can instantiate a class that extends animal. And then, therefore, I can have access to the content of animal through the child. You guys get it? We got it here, right?
Right.
So now I can also say Husky dot eat, right? And then sys out average equals Husky get average weight, right? And then if I print this, I get 30. Remember, the average weight comes from this guy, right? But is overridden in dog, right? And that's what I get from Husky, because Husky doesn't have get overweight, average overweight, right? But dog has it. And as Husky is a child dog, then Husky has access to dog, right? Because Husky is a dog, but dog is an animal. That's why you also get access from the animal. Okay? So basically, you can say, when it refers to inheritance and abstraction, you can say snake is a reptile, right? That's why snake stands reptile. Rabbit is an animal, right? That's why rabbit extends an animal. Husky is a dog. That's why husky extends dog. Eagle is a bird. That's why eagle stands bird. Dog is an animal. That's why dog stands an animal. And cat is an animal. That's why a cat stands animal. Bird is just a generic, like a species, right? It extends the class object, right? Or maybe flying creatures or something like that, you know? But actually, everything that fly is a bird, right? What flies is not a bird? I'm talking about animals, because a plane flies, but you know, a plane is not an animal. It's not a bird. Okay. All right. So, and also animal stands a class object. So this is unnecessary. Okay. You see? It explicitly extends that. Of course, it's there already. That's necessary. Okay. So you guys understand this a little bit better about abstraction, right? You cannot instantiate an abstract class, but you can instantiate a class that extends a concrete class, because if the class that extends the abstract class, it's another abstract class, then you cannot instantiate that one either. So you can instantiate a concrete class that extends an abstract class. Okay. Good. Very good. Let's talk about methods, abstract methods. Okay. 1 second. We're gonna use basically the same classes as before. I don't want to write them again. I just want to add whatever the previous ones didn't have. Okay. Good. So the animal class, and I'm gonna create a method here, say package, and say abstract methods. Okay. All right. So let's enter this guy. All right. Abstract methods. Right. And now let me create an animal class. Animal class. Let's see what's the difference between them. Basically, they are the same with only one exception. All right. So I'm going to copy this guy. Right. Copy this guy. And add it here. Right. And make this class abstract, like I did before, right? So the classes must be made abstract. Now I'm going to add a few things here. I'm going to just create another method here, and we say protected, right? Same class, same class, same package, a subclass in the package. I'm going to say protected abstract void, and I would say print name. Okay, and I'll leave it this way because an abstract method can be left this way. Otherwise, you would have to do that. But that this is an abstract method, so you don't need to put the body of the method. Okay, that's how you can do that. Now, if it is not abstract, right, then you have a problem. You will need the body of the method. You see, guys, the difference. If it is a concrete method, you will have to have a body of the method. If it is an abstract, you don't need to implement it here, right? You can implement it in the class that extends the abstract class, okay? So here, let's make it abstract, right? And let's have, well, I make this guy here, right? And then this one will stay the same. But now we're gonna see print name, right? And call the method from here. And here we're gonna say age equals age. Okay, we're gonna leave it that way. Okay. Now I'm gonna create another abstract method, but this one's gonna be public. Abstract method int, we're returning an integer, and then get weight. Okay. Remember, we don't have to implement it here. If you make it abstract here, then you will have to implement it in the class that extends this one. Okay, don't forget that. Okay. This is gonna be our animal class, right? We was like the one before, but we added two more methods, two abstract methods. We tweaked this one a little bit. Okay, that's what happened. Now the bird class, right? The bird class is gonna be the same. So let me copy this, right? And I will make just a class here, name bird, my bird. This one will not extend anything. We just put the same thing as it was before. Perfect, right? That's it. So we can close this one. Okay. Now the cat class is going to stand the animal, okay? Just like the other one. And guess what? What's gonna be different from this one? Can you guys tell me? What did I say about the abstract methods? Do you think this cat is gonna be the same as the one we're creating? Guys? Guys, you here? What's gonna happen when I do this stand animal? What's gonna happen? Then it's gonna give me an error. Okay. You see, class cat must either be declared abstract or implement abstract method pre-name in animal. You see? Because those methods are, are abstract. Okay? So I have to implement that guy. Okay? So now I'm going to just create this guy like I did before. I'm gonna close this one and I'm gonna say get weight, right? I'm going to return 5. Remember that I'm extending animal, right? And the other one is public void, print name, right? And now the error disappeared. You see, even if I don't put anything here, I have to implement it. That's why I have these guys. If I do this, I get an error, right? Because this is not an abstract method, right? I'm just implementing the method from the abstract, from this animal class, which is an abstract class. But the method is abstract, right? So I have to implement it here, right? What if I do this? I still get an error because I have to implement the get weight. It's abstract too. See, the get weight is abstract, so it has to be implemented as well. So all the abstract methods in the abstract class, they have to be implemented by every single class that extends animal. All the classes, they need to implement this. Okay? And you use the abstract class when you want to make sure that all these methods are implemented in the child classes. Okay? So that will be our cat class. We don't have to put anything inside if you don't want to. We just need to implement it, add the body of the method. Let me take a look at the dog class. The dog class is going to be similar to this one. Okay, the only difference is that we have, or actually there's no difference. It's the same thing. It's the same thing. The only difference is that let me do this. Okay, let me create a dog class. Guys, a little test for you. Okay, are you here? Can you give me a signal? Are you here? Can you give me a signal?
Yeah.
Okay. Yeah. What will be the solution of this error?
You need to
Structure on top of the error.
Add print. What was the print name? What you have something?
So this is extending an abstract class that has abstract methods. What could be the solution?
So you need to extend the animal abstract methods into dog, which are print something, and I can't remember the other.
So I have to implement the abstract methods here, right? That's one solution. The other solution can be just declare this class abstract, and that's it.
Oh, nice.
Right? That's another solution. And that's what we're going to do now. Just leave it like that.
So if you make abstract, if you make dog abstract, then you need to extend dog to, what was that, Husky?
Not necessarily.
You did that. No?
Well, yes. But if you stand animal in the Husky class and you don't declare the class abstract, you have to implement the abstract methods. You have to implement print name and get weight. The only way that you're not forced to implement those methods if you make the class abstract. If you declare the class abstract, then you're not forced to implement those methods.
But
Okay.
I won't be able to access any methods on this one, on the dog,
Yes.
from another class unless I send dog to that class. So if you go to Husky, can you go to Husky?
Husky, I haven't created Husky yet.
Oh, sorry. So when you go to Husky, let's see how that happens.
Okay. Now I can override. I can still override these guys because remember, I'm a standing animal, right? But I'm not forced to implement them because I made this class abstract, right? If I don't make this class abstract, then I am forced to implement method. You see, I have to implement this too, right? So I can say this guy, and I have to implement them. I'm forced to implement them, right? Because those methods are abstract in the animal class, right? So every single class that extends animal has to, with uppercase, all uppercase, has to implement the abstract methods. Unless you make the class abstract, right? And then you don't have to implement these guys, right? You're not forced to, right? So I can give the class dog just like that by declaring the class dog abstract, right? Now, in the case of the eagle class, it's going to be exactly the same as this one. So I'm going to copy this. I'm going to create an eagle class, right? Right. Eagle class is fine. That way, there's nothing new. Now, Husky is going to stand dog, right? It's going to stand dog, okay? So now Husky, I'm going to copy this from Husky, which is going to be the same. I can close this and create a Husky class, right? It's going to extend dog. And then it says Husky must either be declared abstract or implement abstract method print name in animal. So basically, it's telling you to implement print name, right? And also get weight, right? Because simply is extending dog, but dog is a standing animal, which has abstract methods, but also dog has abstract method too, that is inheriting from animal, right? You don't declaring abstract here, but as dog is a child of animal, Husky is also a child of animal because Husky extends animal, extends dog, and dog extends animal. You see, it's just inheritance, guys. It's just inheritance. You are extending a class that has abstract methods. Everyone that comes after that will have to implement those methods unless the class is declared abstract. Okay? So in print name, we're going to say, this out, Husky name, Husky name is get name, right? And then weight, let's return 30. Okay? Rabbit. So rabbit, let me copy these guys from rabbit. We have the same thing here, right? And then I can close this class. Rabbit is going to extend animal too, right? And then I can copy this, right? And then we're going to say extend animal. So guys, what's going to happen now? What are we missing here? What are we missing here? Guys, what are we missing here?
Method?
Huh?
A method? Maybe a method from animal?
Yeah. What kind of method? Guys, what are we missing here? We did it in Husky. We did it in Husky. We have to do it in Rabbit too, because
So
Rabbit.
the print name and the age.
So we have to extend. We have to implement print name, and we have to implement gateway. You know, they're abstract methods, and they're extending animal. Every class that extends animal, we have to implement that. Okay. So now we're returning to, and print name. We're not going to do anything. Okay, so I keep it this way. Okay. Right? Right? We're not doing anything with print name. Now, the other class is reptile. Right? So reptile is going to be the same thing. Nothing is new. Right? So I'm going to create the class reptile. Right? And then I'm going to say this, right? Nothing new, same thing. And then the class snake is going to just do the same thing as this one. So I'm going to just copy this and then say snake. And stands reptile. And then we say this. You see? Perfect. Okay. Now let's see the main class. So the main class has a little bit more methods. Okay. So I'm going to delete this one, and say probably after methods main. Right? And now I'm gonna say Java class, I'm gonna say main. Right? Now main, I'm gonna say that our friend, the main method. I'm gonna say Husky, right? I'm going to move Husky here equals new Husky. And then we're gonna pass H5. Okay. I'm gonna set the name to Husky. I'm gonna say Rex. Okay. Now I'm gonna say Husky, print details, and say Husky, say H, set H 6. Okay. And now we say Husky, print details. Right? And now we can say sysout weight equals plus Husky get weight. Okay, remember that get weight is it's a method that we implemented in Husky coming from the animal class. Okay, it was an abstract method in the animal class, so I am making sure that this method is implemented in the classes that are extended me. Okay, so now it should be 30, the result here. Okay, let me run this guy. And then we have this guy here. So Husky's name is Rex. Age is 5. Right here, age is 5. And then Husky's name is Rex. And then the age equals 6 because I set it to 6. Right? And then I'm getting that result. Print details, which is this guy. Age equals 6. Remember that print details, we said H equals that. We remove name. Remove name as before. Because we are printing the name here, right? Which is Husky, right? We don't need to put name here. Okay. Now we get the weight. Return is 30. Like we take a look at this. In Husky, we're returning 30 here. That's why we get 30 here. Okay. Now I can say Husky eat. I can just do that. Husky eat. And then we can say sys out average equals, and then we say Husky get average weight. Okay. And now if I print that, it's basically almost the same results. Average 30, dog eating, right? Just eat. But remember that when you call Husky, right? And then you call that particular eat, right? Then it comes to this, right? Husky eating. You see here Husky eating. And then it called the superclass method eat, which is in dog. And then it prints dog eating, just like it says here. Guys, I don't know if you understand this spaghetti ball here. Do you guys understand it?
Yep. I do.
Yes? Only Maria? I have 8 students in class. Only Maria understands this. How about Ossie? How about Anand? Eugenia? Luis? I'm sure that Luis understands this. Michael Montalban? Otmaro? Neil?
Repeat the question, sir.
Do you guys understand this chaos here? This chaos? All of this that was done? Explaining after methods?
Yeah, you mentioned you extend the class to animal. You make it an abstract class, I guess, so you don't have to override. So you don't have to override the method again in the previous class you were showing.
Yeah. You can create an abstract method in the parent class, and then every single class that extends this class will be forced to implement these methods. So you don't have to implement it here. So this is a mistake, right? This is an error. You don't implement this here. Now, when you do the cat class, for example, you don't have to put anything. Just by putting the body of the method, which is empty, then you are actually implementing that method, right? But you're not putting anything inside. In dog, you are actually, but dog is not implementing that because I declare the class abstract, so you're not forced to do it. But in the case of Husky, Husky is not an abstract class; it's a concrete class. You have to implement those methods. The same with rabbit, right? And that's it, because reptile doesn't extend animal, and snake just extends reptile. Okay, nice.
Yes, got it now.
Okay, so let's talk about interfaces. Okay, interfaces. Okay, just give me 1 second. Okay, so let me put this here. All right, so implementing interfaces. Well, when you implement an interface, what you do is just put the class name, right? And you put the word implements, right? With classes is extends. With interfaces, you implement. Okay. So Java doesn't support double inheritance, right? Double inheritance. That's why we have interfaces that you can implement. It's like daily life. Like in real life, you cannot have two parents or two fathers, right? You cannot have two fathers. You only have one, right? Maybe someone else raised you, but you only have one father. Same in Java. You can only have one parent, right? So I believe that when Java was created or object-oriented programming was created, I believe, that's my personal opinion, the person was religious. I believe that the person was Christian or something that thought about life like the object, the big object is God, and then you have a father, and then you can extend your father. You inherit the traits from your father, and then you can also have a godfather or probably a stepfather, right? Just in case your parents divorce, your mother, your father marries another woman, another man, and then you have a stepfather. Something similar to this. You cannot have two fathers, but you can have a father and a stepfather. Similar. You can extend a class, but you can also implement an interface. Okay, so that's to even add more inheritance to your class, right? So you put the name of the class here, of course, the access modifier, the keyword class, the name of the class, implements keyword, right? And then the interface name. Okay. Now this is implementing method, right? That was declared in an interface. It's an implementing method, right? The difference between, we're going to see the difference between abstract methods and abstract methods and methods from an interface. Okay, so that's one thing that I want to show you. What are the default interface method rules? Default methods, because you can have default methods in which are not abstract methods. You can have default methods in an interface. Can only be created in the interfaces and not within an abstract a class or abstract class. Default methods can only be created in an interface. Okay, not within a class or abstract class. Default method must be marked with default keyword and provide default implementation. Needs to have a body. Okay, the default method needs to have a body. Okay, it's not like the abstract method that doesn't need to have a body. Okay, or doesn't have a body. No, doesn't have. Default methods is not assumed to be static final or abstract, as it may be used or overridden in classes that implement the interface. It's just like the abstract methods in the abstract class, they're not final, right? So they can be overridden, right? Default method is assumed to be public, and it will not compile if marked as private or protected. A default method has the default word. It's not private or protected. They may use that to trick you in an exam. It cannot be private or it cannot be protected. Okay. What else? You can have static methods too in the interface. Static methods in interface is assumed to be public. I will not compile if marked as private or protected, right? That's a static method. And to reference static method, a reference to the name of the interface must be used. Of course, it's like when you declare a method static, you don't have to instantiate it in another class. You just refer to the name of the class dot the method, just like we did before with static. Same thing with interfaces. If a method is static, you just put the name of the interface dot the name of the method. That's it. Simple. Okay. And create an interface. Well, you put the word public, depending on what is the access modifier. Interface, the keyword interface, instead of class, you create an interface. The name of the interface, the default, this is the variable that you declare in the interface. Is a constant, right? And by default is public, static, and final. Okay, that's something that you have to remember. A variable in an interface is by default public, static, and final. Okay, it means that if you implement this interface, you will have to access this variable by just putting the name of the interface dot the variable, because it's static, right? It's final because it cannot be changed, right? This value cannot be changed, right? Now this is the an interface method, right? It's a method declaration. By default, is public and abstract. It means that if it is abstract, it doesn't have a body. Remember when we saw the abstract methods in abstract classes? It doesn't have a body. If it is default, if it is declared default, it needs to have a body. Okay? A body is just the curly braces opening and closing. That's the body. Okay? If it is default, if it is like this one, if it is public abstract, it needs to have, or it doesn't need to have the body. Okay? Let's see it in more details in an example, right? So these interfaces. Okay? And my question is, what would you use an interface? Well, let me read this to you. To declare interface, use the interface keyword. It is used to provide total abstraction. That means all of the methods in an interface are declared with an empty body and are public, and all fields are public, static, and final by default. What is the field? What is the field? The field is the variable, right? The variable, that's the field. See? This is the field. This field here, a variable, okay? Is declared public, static, and final. A class that implements an interface must implement all the methods declared in the interface. To implement an interface, use implements keyword. Okay? The good thing about interfaces is that imagine that you have tons of classes that implement interfaces, right? If you want to change something, it's gonna be so hard to change it, to change all the classes, all of the methods of the classes. What you have to do is just simply change the interface, and that's it. Okay? So the good thing about this is you can change the interface, right? Since Java does not support multiple inheritance in case of class, but by using interface, it can achieve multiple inheritance. Okay? I would say multiple, well, multiple inheritance, I don't like it. I like a father, stepfather. It is also used to achieve loose coupling, like decouple your application, right? And make it more robust. Interfaces are used to implement abstraction, right? So you implement, right? You implement the details, the implementation of the details. So the question arises, why use interfaces when we can use abstract classes? That's a good question, right? Well, the reason is abstract classes may contain non-final variables, whereas variables in interfaces are final, public, and static. Okay? So that could be a difference. Okay? Let's see in an example. Okay? So now I'm going to create another package, and I'm going to call it interfaces. Okay? Right? Oh, I created a class. Sorry about that. Okay, so I'm going to create a package and call it interfaces. Right? Call it interfaces. So I'm going to create another class named animal. Right? I'm going to do the same thing with the animals. Right? And then I have animal and animal. Let's see. Let me take a look at the animal class for interfaces. Okay. I think it's the same thing. See, same thing. So I can come here to this animal guy, and copy of this, right? Close it, and then copy here, and I will
Interface animal.
declare the class abstract. Okay. Perfect. So I have the animal here. Okay. Perfect, perfect, perfect. That's it. That's all I need. Bird. Okay. Bird. Bird is going to be the same. Where's bird here? Did I close bird? So bird is going to be the same. Okay. Bird is going to be the same. Right. Now, cat is going to be the same. Okay. Okay. So I can create a class cat. And cat stands animal. Perfect. Right. Now I'm going to have dog, and dog basically it's the same thing. So dog will be abstract and do the same thing here. So I'm going to say dog. Perfect. I'm going to declare this guy abstract, and it will extend animal. Perfect. So now I have dog. Eagle is going to be the same, right? And it will extend bird. And eagle extends bird, right? Perfect. Now I'm going to have an interface right now. So we're going to create an interface, right? And I'm going to select here interface, and I'm going to say has tail, right? So it creates an interface for me. Now the interface is going to have by convention, all the final variables are written in uppercase. Okay. Okay. So that is a final variable, right? That's a final value, right? I'm gonna say int get tail length, and then I'm gonna say this, and that's it. This is an abstract public method, okay? Right? Because by default, they're public and abstract, okay? By default. If I want to make it default, then I will have to do something like this. Default, right? And then I would need a body. So I won't have to do this, right? You see, if I make it default, I need to have a body, right? But I make it abstract, so I don't need that. It's by default public and abstract. Okay, that's good, right? So now we continue to the Husky. That's it. We don't do anything else in the interface. We just declare things, but we don't implement anything. We're gonna implement them in the classes that extend the interface. Okay, so Husky now. We do Husky now. Let me take a look at Husky. So Husky extends dog. Husky eating. And then Husky print name and return weight. Same thing. Let me just copy this guy. Close the Husky class. Create it here. Right? and then Husky stance dot, right? And then we copy this, and that's it. That's all we need for Husky. Okay, now we have rabbit, right? One moment. Okay, so we just created this guy, right? Husky. Now we have rabbit, and rabbit's gonna be basically the same as the other one, rabbit. So we just create a class named rabbit, right? And then rabbit will extend animal, and then we do this. Perfect. Now our reptile class is gonna be the same as the other one. Okay. So we close reptile. And then reptile doesn't sting anyone. We have snake. Snake is gonna be the same. Right. Right. And then we have this class named snake. Right. And then snakes stands reptile. And then I have this here. Okay, and my class is complete. Okay. So now in the main guy, so interface is main, right? Interface is main. Then I create a main class, right? And then the main class will be exactly the same as the other one, right? Let me just do this, Husky, and then there'll be Husky from interfaces equals new Husky, and then we're passing 5. Okay, we say Husky set name. Well, Husky set name, and there's a Rex. And then we say Husky print details, and then we say Husky set age. We say 6, and then we say Husky print details. Perfect. And then we say this out. Weight equals Husky get weight. And then we say Husky eat. And then we say this out. Average equals Husky get average weight. Okay, finally, we'll finish this guy. Okay, so we get everything, nothing changed. We're not implementing anything yet, right? Now what we have to do is just implement the interface, okay? Any questions so far?
Nope.
No
No.
questions.
Okay. Okay. Okay, let us do this. Just give me 1 second. You see, that's how you create an interface. Okay. So let's create now other interfaces and let's see how it works. Okay. Okay. So let's create, so we have this interface, right? We have this interface that we created. That's fine. Okay. That's fine. So now let's create another interface, and I'm gonna delete all, close all these guys because we're not gonna need them now. This which is just a demonstration. We're gonna use them later. Okay. So now we're going to have this interface. I'm going to create another interface, right? But this time I'm going to call it herbivore. Okay. Herbivore. Right? So that's going to be an interface, right? Now this interface is going to have a default method, right? It's not going to return anything, and it's going to eat plants. As it is a default method, it needs to have a body. Okay? I'm going to say sys out eating plants. Okay? So basically, interfaces, they, facilitate multiple inheritance. Okay? Eat plants. Okay? That will be my interface. Okay? I'm going to create another interface, and the name is omnivore. Okay, omnivore. So this interface, okay, something that you need to understand. Equals extends equals. The meaning of that is that interfaces can extend interfaces. Classes can extend classes. Interfaces can extend interfaces. So now we're extending another interface, herbivore, right? So interfaces can extend interfaces, right? To acquire more implementations, okay? Now, I'm gonna create another interface, but this one is gonna be named carnivore. So I'm gonna, so far I have 4 interfaces. I have Haskell, herbivore, omnivore, and carnivore. Okay. Right? And omnivore is gonna extend both herbivore and carnivore. So you can extend 2 interfaces if you want to make it even more extendable, right? You can do that, right? Okay. So we have this guy, right? We're gonna keep it that way for now. Okay. Now rabbit, it's right here.
Is it extend or is it implement?
No, classes implement interfaces. Interfaces extend interfaces. Equals in equals extend each other, right? Classes extend classes and interfaces extend interfaces. A class implements an interface. You got it?
Maybe.
Okay, Maria, omnivore is an interface, right?
Uh-huh.
Interfaces can extend other interfaces. A class implements interfaces. A class doesn't extend interfaces, but interfaces can extend interfaces.
I see.
So equals extend equals, like Classes extend classes. Interface extends interfaces. Okay. But a class doesn't extend an interface. It
It implements an interface.
Okay. So rabbit right now is extending animal, but it's also implementing herbivore. Right? So that's what guarantees multiple inheritance. That you can inherit from animal and you can also inherit it from herbivore. What you cannot do is this. Like this. That doesn't exist. Because you can only extend one class. Right? But you can implement herbivore and carnivore. You see? You can extend one class only and only one class, but you can implement several interfaces. Okay? In this case, we're only implementing one interface, herbivore. Okay? Now, we're going to not anything else to do. Okay, we're just implementing this. Okay, that's fine. We're just implementing this. That's fine. Implementation, right? Now, Rectile doesn't have anything, but we have an interface called walk. Okay, so we're just playing with interfaces. Okay, walk, right? It's an interface called walk. Now this guy has a default int, returns an int, get speed, right? Method. And then the body is return 5. Okay? Now I'm going to create another interface, right? Another interface named run, right? Name run, right? Now this interface, can I extend walk? Walk is an interface, right?
Yes.
Can I extend walk?
Yes.
Yeah, what did I say about equals, extend equals, right? I can extend walk, right? So that's fine, right? So that's fine. I can extend it, right?
I need a break.
You need a break? What time is it?
It's 7 o'clock.
Yes. Thank you, Maria. I just forgot about the break. Thank you.
Oh, no. Okay, thank you.
Yeah, I see you in 10 minutes. Thank you. Okay, guys. Just give me 1 second, please. Okay, so we have the interface Haskell. We have the interface herbivore. Okay. We have the Husky class. Husky. Okay, so Husky is going to have, well, let me create the dog class first. Okay. The dog class here is going to extend animal, but it's going to also implement Haskell, right? Haskell. And also, let's create another interface that's going to be can run. Okay, that's another interface. Okay, so can run. Okay, so the interface can run has a method which is default. Well, it's public. I'm sorry. Void run, and then int speed, right? And remember, this is an abstract method that has to be implemented in the classes that they implement this interface. Okay, so dog will implement Haskell and can run. Okay, can run, right? Now, dog has override get weight and eat. Okay, that's fine. Eat all this. So Husky, let me bring Husky up. Husky has a problem because dog is implemented Haskell, right? So now Husky has to extend dog, and at the same time, it has to just the implementation because dog has can run is declared an abstract class. That's why dog is declared abstract class. That's why it doesn't have to implement those methods. But can run has this method here, and Haskell has this method here. So that has to be implemented in Husky. Okay, so in Husky, we have to say get tail, right? I don't know why I have this default tail. It's like this, not default tail. So Husky can do this get tail length, right? And we're going to return 20. Okay? So it's just implementing a method from the HasTail interface, right? This is a public abstract method that has to be implemented in any class that implements that class, right? But in this case, as dog is, as Husky is a standing dog, but dog is implementing HasTail and can run, then Husky has to implement those. Why is not dog implementing those methods? Because dog was originally declared as abstract, but Husky's not. So Husky has to implement those methods. So the other one is run, right? Run. And run comes from can run interface. Okay? Can run is here. Run, right? And then we have to pass the speed, right? Now we can say sys out Husky is running at speed. And then we say speed. Say miles per hour, right? So guys, why do we have to implement these guys? Because in their interfaces, they're abstract. Remember that methods in interfaces are by default public and abstract, right? And they were originally declared as abstract here. We didn't put the abstract word, but they are abstract by default, and they don't have a body. So you put a body here. Abstract methods don't have a body, but they have to be implemented in the class that implements this interface. In this case is Husky. But Husky does not implement those interfaces, but extends dog. Dog implements those interfaces, but dog is abstract. That's why you don't have to implement them here. But you will have to implement them in any class that extends dog. Okay? Any class that extends dog, we have to implement those methods. And that's why we have Husky here. And Husky implements those methods. Okay? So, cat, the cat class, let me bring cat, will implement run, right? Right. Okay. Okay. But don't forget that dog or animal. Where's animal here? Animal. I have so many classes here that hard to see. So what is animal? The animal's here. Okay. So animal has abstract methods that cat already implemented here. Get weight and print name. But then cat is implementing run, right? And run is an interface. Run doesn't have anything. Okay, that doesn't matter, right? We're just implementing an interface that doesn't have anything, right? We can say here probably we can say string text, right? And we can say probably string print text, right? And then we can say string text, right? And then in cat, we can say print text, right? And then here we can say return text, All right, perfect. So we're just implementing this guy, right, from cat. I mean, we implementing run in the cat class. All right. So guys, it's a mumbo jumbo here, but what you have to understand is that you can implement classes to make your class more robust, to implement other methods and things that you can, make your class more extendable. Now, interfaces, it's a way to abstract the information. Okay? So interfaces is what people see. People don't have to see the other stuff. It's like when you see an interface in front of you, like a user interface, right? Like a website, you don't see anything behind it. So what people see is this. That's it. They don't see any implementation. There's no implementation. It's like when you show someone a car, like I said before, they don't see anything. They don't need to see the implementation. They just see the car, right? And they're not thinking about the implementation. Okay? So you can achieve more abstraction by using interfaces. Okay? So now I think that I have to create another class, right, named bear. Okay? Bear. Right? Class bear. So this class is going to extend animal, and at the same time it's going to implement omnivore, right? And we have several issues here that we have to resolve. First of all, we have to implement this method from the omnivore, from the herbivore. The herbivore, where's herbivore? The herbivore interface. But remember, omnivore is extending herbivore and carnivore. So if we implement omnivore, we're going to get all these guys for sure, because this guy's extending the other interfaces. So we have bear here that is extending animal and implementing omnivore. So we have to implement eat plants. So we say, is this out? We say bear eating, or bear is eating plants. Right? Now we have to implement eat. One moment. Where's the carnivore here? I didn't put anything here. Okay. One moment. Okay. So here we gotta say default void eat meat. And then we're gonna say out eating meat. Okay, perfect. Now in bear, we're going to implement that. Okay, we're gonna say eat meat, right? And then we're going to say bear eating meat, because we are overriding it. Okay, out bear is eating meat. Okay, we have to continue overriding because we need, animal has other abstract methods that we have to add. So get weight would be one of them, right? Get weight, and we're gonna return 2,000 pounds. This is a bear is a heavy animal, right? And we have to implement another one. We have to implement print name, and then that's it. There's nothing else that we need to implement. Now we say this out, and we say bear. Okay. So as we are extending animal, we have to implement get weight and print name. Those are abstract methods that are in the animal class right here. You see, print name and get weight. Those are abstract methods that have to be implemented in whatever class that extends animal. Okay. Now, in the bear class, we are implementing omnivore. So omnivore, which is an interface, extends herbivore. So herbivore has eat plants. And you can see here, we have eat plants in bear. But also, omnivore is extending carnivore. Carnivore has eat meat. That's why you have to put in bear, eat meat as well. So you have to implement every single method that is abstract, either from the class animal and from the interface omnivore. Even though the interface omnivore doesn't have anything, it is extending other interfaces that have abstract methods like eat meat. Okay, actually this is not abstract, it's default, but herbivore has eat plant. So they have to implement that. Okay, there you go. You see them here. Okay, if I delete these guys, right, I don't get any issues. Why? Why do I get any issues? Can someone tell me why I don't get any issues when I comment this out? These are the methods from omnivore. Why I'm not getting any issues here? Whereas if I do this, I get issues. You see? Why I'm not getting any issues if I do this? Can someone tell me? If you're here. If you're here, can you please tell me why I'm not getting any issues here? Guys, are you here?
Sorry, I was talking on mute. Because you are using an interface. Those are coming from an interface, right?
It's coming from omnivore.
And the interface is public. Herbivore and carnivore are what? You go there. So it's public also.
Why I'm not getting any issue in bear if I comment this out? Why am I getting an issue now? Why am I getting an issue now? And why I was not getting an issue before?
Those are defaults.
Correct, because both methods, either from the carnivore and the herbivore, are default. If they're abstract, so this makes the method automatically abstract, right? Because by default, they're abstract and public. So that I will have to implement it no matter what. You see? Now I have an issue here, right? Of course, if it is abstract, it cannot have a body. So we have to do this, right? And now, of course, so I cannot have a body. Now, here, I have a problem. And the problem is that here, well, it becomes more complicated. I don't want to do that because I will have to fix the entire thing. So I will make the method like it was before, a default one. But for you guys to understand that if I make the method abstract, it has to be implemented. When it's default, you're not obligated to do it. Like here, if I comment this out, nothing happens, right? But if I comment the other two out, it means that I'm going to have an issue because in animal, they come from animal. In animal, these two methods are abstract. Okay? So I have to implement them, right? I think this is ready to be, you see Cameron here. This is ready to be tested with the main method. Okay, cat, eagle, perfect. So let me just test it with the main and let's see what happens. Okay, so the interface's main is here. So now I'm gonna give this way. This one will stay this way. Print details, H6, print details, Husky weight. Okay, but before I do this, I want to say Husky dot run, right? And say 10. So what is it coming from? What is this coming from? Well, if we check the class Husky, we see that we implemented this method from the dog class, right? But the dog class is abstract. We saw that the dog class is abstract, right? And the dog class extends animal and implements hashtag and can run. And can run has the method run. That's why Husky is getting that method from here, right? Right? And we're passing the speed. Okay, so now if we print it, it's gonna say Husky. Well, actually, when I say, wait, that, yes, it said, because I've run this before. Husky is running at speed 10 miles per hour. So it's right here. We're passing the speed here, right? Then we can say, sys out, tail length, equals Husky get tail length, right? And now if we do this, we get tail length 20. Why 20? Well, we come to here, right? And return 20. It's right here. Okay? So that's why we get 20. We continue with main. We say Husky eat, average weight. Now let us create a bear object. Bear equals new bear. Right? That's a new bear. That's a bear. Okay. Now we can say bear, set name, and we say Jimmy. Okay. Jimmy. Remember that bear is just is extending animal. Even though we don't have a constructor here that accepts anything, it's extending animal. An animal has a method, name, set name, right? Set name. That's why we're using set name here, right? Set name here, right? Now we can say bear set age, and we can say 10, right? And we can say bear eat meat, right? And if you take a look at the class bear, we have this method here, eat meat. So it's gonna print bear is eating meat, right? Now we can say bear eat plants, and it's gonna print this guy here, bear is eating plants. Okay. Now we can say bear print details. Well, if you come back to animal, in animal you see that you have print details here. It's gonna see H equals H. Bear, the H is, let me go back to animal, the H is 10, right? It's gonna print that. Now, let's print what we have here so far. Let's just print it. What do we get? So we get bear is eating meat, bear is eating plants, bear is being printed, and H equals 10. Okay, so we're doing that. Okay, so let me see here, bear.
Where is bear coming from?
I'm sorry?
Where is the word bear by
Right here.
itself?
Right here, print name.
Oh, okay, I see.
Yeah, we're printing print name here.
No, I think it's when it's running there.
Yeah, it's just the constructor. You see?
It's part of the constructor.
Okay, bear is eating plants. That will be meat, plants, and then print details. Print details will come with, let me see here, bear. Yeah, print name, bear. But let me come here. Yes. Animal. Right here. You see there? When you call print name, print details, let me just bring you here. One moment. In the main class, when you bring print details, it immediately calls, where's animal?
Print name.
Print name.
And then prints the age.
Correct. Right here. Prints the name and prints the age.
Okay.
So that's
okay,
that.
good.
Okay. So that's it. So far, so good. Okay. So far, so good.
Yes.
So we're just implementing interfaces, like making this class more robust, like adding more things. Probably things that are not in a class, we can implement it in an interface. Okay. Now I'm going to create rabbits, right? Rabbits equals new rabbit, right? But for rabbit, we have to, oh, it imported the class already. That's fine, perfect. So we say rabbit, and then we say, well, we come here to rabbit. Where's rabbit? Rabbit. Rabbit has this method here. Rabbit implements herbivore, right? And herbivore, come back to herbivore. Where's herbivore? Right here. Herbivore has a default method, eat plants, right? It has eat plants. It's default, so it means that you don't have to print it. You don't have to implement it. But you can do this. You can do this. You can say rabbit dot eat plants. Okay. Even if you don't implement it in the class rabbit because it's default, that's why you don't have to implement it. If it is abstract, you have to implement it. But rabbit inherits that from herbivore. So rabbit is extending animal and implementing herbivore. It's inheriting everything from animal and inheriting everything from herbivore. Even though it's not here, it has access to that. It's like a child has access to his parents or her parents' things. Same thing. Even though the child doesn't have it, it's not his own. It's still, the child still has access to that, like if it is his own, like it is his own. I don't know if you understand what I'm saying. It's like now, Maria is my mother. It's an example. You know, Maria is my mother. Just use Maria because Maria is in class. Maria is my mother. Then Maria has a car. Whose car is it?
Maria's car.
Maria's car. Can I use it? If Maria relies on me, okay. If Maria trusts me, can I use it?
Only if I extend my car till.
Okay. It's more difficult with Maria, you know, but I can use it, right? So I have practically access to everything that Maria has, okay? Even though I don't show it to people, even though I don't have it with me, it's still mine. I can use it whenever I want, okay? So even though in the class rabbit, eat plants doesn't show, I can access it when I create an object right here because it comes from the herbivore interface. And don't forget that rabbit extends herbivore. Okay, so that's how it works. So we continue. I can say cat equals new cat 3. Remember that cat has a constructor that is passing the age, right? Right? So now, if I take a look at the cat class, what can we get from it? Let's analyze the cat class. So cat class has this constructor, and that's why we're passing this age, because it's taking an age here. It's calling the super class constructor age, which is animal, right? Animal is here. So this is the constructor for animal. So it's going to print animal, right? And then after that, it's going to, we're going to call, or we're going to get the speed of the cat. Remember that cat implements run. Same thing. Run is not here, but run has a method name speed, get speed. So let me see, run here. We have run, but also run extends walk, right? And walk, that's the method get speed, right? So basically, as cat implements run, cat has access to walk, because run extends walk. Guys, I don't know if you understand what I'm saying here, but this is crazy, but it's understandable, right?
Yes.
It's like, let's see, it's like I am the child, my father, right? So I extend my father. My father extends my grandfather. I have access to my grandfather's stuff. Okay? It's the same thing. Remember that cat is implementing run, right? But run is implementing walk. So by default, cat has access to walk. Okay? That's why we can say walk has this get speed, right? That's why we can do this real quick. We can say int speed equals cat dot get speed, right? And that's going to return number 5, right? And we can store that in a variable named speed, an integer, right? We're calling that method from the cat class, but don't forget that cat implements run, and run implements walk, and walk is the one that has the method get speed. Same thing we can do, cat that print text. Remember that cat run has this print text, right? So we can say this and say hello from the run interface, right? So simply we're passing that to the method print text, right? And then, well, we are not returning anything here. So yeah, I don't know where the return text go, right? What happened here? Oh, I have to see where it is implemented. Let me see. So cat, right here. So print text, and then we're going to get that in a variable name text. Okay, perfect. Because we're returning something. We are returning something from this guy. Remember, this guy is just declared here, but is implemented in the cat class. It's not a default. Don't forget, it's not a default method. It's an abstract method. Where is it? Run. This is an abstract method. If I make it a default, I have to put the default word. Okay? And of course, if I put a default, I need to have a body, right? But this is an abstract method. Abstract methods don't have body. All right? So now I can say sysout The cat speed is speed miles per hour. Okay? And we can say text, right? Right? So now if we print this, this is what we get. Okay? So hello from the Ron in the face. Right here. Guys, another way that we can do this, and we can do the same way, I can say this out, cat get speed. Right? I can do this. The cat speed is same thing, miles per hour. Right? Remember this, what is this? Guys, if you think about this, what is this? What can be this substitute by? Number 5, right? Because that's what we're returning, number 5, this 5 here. So this is actually this. Same thing, right? This is just what the method returns. And I can say here, same thing. Cat, that print text, right? And of course, I have to pass the test here. Okay? So we can say this 1, and this is 2. And then we can say this 1, and this is 2. Right? For you guys to see it better. So now I get it here. We say the cat speed is 5 miles per hour, that's 1. The cat speed is 5 miles per hour, that's 2. Hello from running to phase 2. Hello from running to phase 1. All right? Okay. Okay. So I would do this so it can get organized. Right? More organized here. It's because I have 2, 1, and then 2 first, and then 1. I do that way so I can get 1 and 2. Okay. So I still get 1. All right. You see? Mm-hmm. Mm-hmm. Yeah. So what I have to do is just print here text, and then you get 1 and 2. Mm-hmm. Perfect. So guys, what do you think? What do you think, guys?
It's complex. It's a lot to remember.
Yes.
Which
Yeah, I mean
is
it's
what.
I mean it's a little complex, but it's just that it's a long program. But basically, we are implementing interfaces to achieve multiple inheritance, because there may be classes that are missing some or don't have certain methods that you can have them in an interface, right? And then you can use the interface to abstract the information, right? And at the same time to make that class more extended. Okay, so now I'm gonna stop here. We have 42 minutes, 48 minutes, right? Actually 38 minutes. I want to give you the chance to implement this on your own. Okay, so I want to give you a chance, just like we did last Thursday, Maria. Does anyone else want to volunteer? Because it's always Maria and Anand. Anyone else? Guys, if you don't know how to do it, it doesn't matter. That's what we're here for, right? So we're going to create abstract classes, concrete classes. We're going to create interfaces, right, with default methods and abstract methods. Let's see how it works. Let's do it. Okay, let's do it. Let's create a class. Let's think about, for example, something that it may be generic, like planes, right? A class named plane. And then the plane, you have a class probably that is a Boeing 700, for example, or a private jet or something, you know, like a model of a plane. Just an example, right? And those classes will extend the plane class, but the plane class is going to be abstract. So we can have some abstract methods, right? Some methods that are not abstract, and some methods are abstract in the plane class. So the other ones we implemented create another an interface that says can fly, for example, in the name of the interface, and create an abstract method or a default method and try to implement that interface in another class. So extend the plane class and implement the interface can fly. Let's do that. And then from the main class, you can play with that, call an object, just get an object, call the methods from the interface, call the method from the abstract class, call the method from the concrete classes. Let's see how it works. Let's see it. But that's the way that you can learn it better, by doing. You learn by doing, right? So I want someone to volunteer. If there's no one else, wait an ant, you're gonna be the subject, you know, again. The subject study again. Or Maria, probably you want to do Maria. Why not? And Maria, what do you think? What do you think?
Share my window. I can share my window. I still have to look at this again. There's so much stuff going on.